Hi, this is Miss Carly, and this is your flip video for 7.1 Logarithms and Exponential Functions. Today we're going to practice rewriting exponential equations and logarithms. Sometimes it's easier to solve equations in exponential form. Sometimes it's easier to solve them in logarithmic form. So today that's what we're going to work on. All right, so this is the logarithmic equation basically that we did in the duckweed activity today. We have y equals 2 to the x power. So it's exponential because your variable is the exponent. If we make a table of values and we just plug in x's from 0 to 3, we get that our y's are 1, 2, 4, and 8. And if you notice, they're all going up by a multiple of 2. That's our growth rate. And we call this term the base, right? Base exponent. That vocabulary shouldn't be new. All right, now if I switch the x's and the y's, which is finding the inverse, you notice that instead of your y's going up by 2, your x's are going up by 2 when your y values are only going up by 1. That inverse is called the logarithm. The correct way to write it is the word log and then that little 2 underneath it. That's also called the base. So that should be pretty easy to remember because whatever your base is in the logarithm should be the same as whatever your base was in the exponential form. Now, the good thing about logarithms, when we switch our x's and y's, y is now the exponent. So if you have to solve for x, and x is an exponent, if you switch it to a logarithm, you should have this number, and I'll show you how to plug that into the calculator. If you look, you only have 2 log buttons. All right, so your choices for plugging logarithms into the calculator are limited. You have that log button, and you have this one that's called ln, that stands for the natural log. If you notice in our equation, our base is 2. Well, your calculator only has 2 choices. You either have to do it with a base of 10, which is the log button, or a base of e. E is not a variable, it's a number like pi, it's like 2.7 something. And if you forget, the exponential form is right above it to help you remember. All right, so if you were going to try to plug something into the calculator, let's say I wanted to know how many terms it'll take. Basically, what would I have to raise the number to? What power would I have to raise that to? Before I got close to the number 100. Well, you could guess and check and just keep trying to see if you could get there. Or I can just change it to a logarithm and my 100 would now go there. All right, so basically with the logarithm, I'm trying to figure out what exponent I would need to get my answer up to 100. So the way you would have to type this into the calculator is called change of base. The bigger number is called the argument. You can think of it like your answer, right? Like I want for my answer to be 100, so that goes in the spot that's called the argument. That needs to go in first. You would have to hit log 100 divided by log 2. So in the calculator, it would have to look like this. Log 100 divided by log 2. We have to do it that way because our calculator doesn't have the same base in that button that our base does on the problem. All right, and you get about 6.6. All right, and if we check it, if we do 2 raised to the 6.64 power, we get pretty darn close to 100, so that's probably it. All right, so basically, I was looking for what exponent would make my answer 100. If I change that to a logarithm, I can just use that little change of base formula and figure out the answer. Sometimes that's easier. Because you could always, if I plugged 100 here, you're always allowed to use y1, y2, second trace 5, but sometimes by the time you zoom enough to find this intersection, it's easier to just do this and you have the right answer right away. All right, so over here we're going to practice rewriting these as either logarithms or exponential functions. So number 1 and number 3 are already exponential functions. So I'm going to need for those to be logs. And number 2 and number 4 are logarithms. I'm trying to make them look like exponential functions. Alright, so when I go to rewrite this, the first thing I'm going to do is I'm going to notice that the number 10 is my base. That tells me I'm going to have that little 10 after the word log. That's where your base goes. Alright, the argument is the answer to whatever this was. So that would be x. And whenever we rewrite a logarithm, the exponent, basically your goal when you rewrite it in a logarithm is for whatever your exponent was to be by itself. So if 2 is my exponent, when I go to rewrite it, it should be by itself. Alright, now you should be able to tell if your goal was to solve for x, this form would be way easier to use. Right? Alright, let's do the same thing with number 3. The first thing I'm going to do is recognize that my base is e. So I'm going to go ahead and put that as my base. And your answer is your argument. The goal is to get your exponent by itself. Alright, now we don't usually write log e. This is just one of those little symbols that you need to know. Anytime your base is e, the opposite log that you want to use is ln. That was that natural logs button. And if you notice on your calculator, it has an e to the x right above it. Right? Because they both have the same base. That base is e. Alright, now this might look a little bit weird, but you can plug that into the calculator. Just push ln4. And that would be how easy it is to get your answer for that one. So for this one, the log form would definitely be easier to solve for. Alright, number 2. Now this trick, it's called a wheel, but it doesn't really make a full wheel. You should be able to tell that this little number here is your base. So that means when you go to rewrite this, you need to start with that 8. Now it wouldn't make much sense for you to try to do 8 to the x power, right? Because the whole purpose of rewriting this is to move everything around. This is your exponent. Remember, in a logarithm, your exponent is already by itself. So that becomes my new exponent on my 8, and that would equal x. Alright, this is going to be way easier to solve for. You would just have to do 8 to the 3rd power. Alright, let's try this one. Now, this example, I don't have a little base there. It's kind of like whenever you have a square root, there's an imaginary 2 that just nobody talks about. Anytime you just have the word log, people assume that you know that the base is 10. Right? Just like on your calculator, if it's just regular log, above it you have that base 10. So that's the base that you need to start with when you go to rewrite. You're not allowed to just leave it blank. Alright, so again, 5 is actually the exponent that needs to go on the 10. And your exponent would be, your argument would now be where your answer goes. Alright, so I'm going to show you how to kind of use the wheel trick with number 2. You start with the base, and you go around to the other side of the equal sign. That's your base, that's your exponent. 8 to the 3rd power. And then it's just equals x. Alright, it would work the same for number 4. You would just kind of have to write the 10 in there, in that spot where the base is supposed to go. Alright, if I try to use the wheel, it would be 10 to the 5th power equals x. Whenever you have to go into the logarithm, you can use the wheel to check. This should be the same as 10 to the 2nd power equals x. And you can just kind of use that to help you check. Alright, so let's look at some solving real quick. Alright, number 1, you could definitely just do y1, y2, second trace 5, but I'm going to rewrite this as a logarithm. So I have log, my base is 3, and again, the purpose of this whole thing is so that your exponent is by itself. So that means that x plus 1 should be over there, and this should be 5. And I can always use the wheel to see if I did it correctly. 3 to the x plus 1 power equals 5. This is actually super easy to solve in your calculator. If you just do log 5 divided by log 3, you have this entire side taken care of, and you just need to subtract 1 from both sides to get x by itself. All right, number 2. This is already in log form. This is not going to be easy to type into the calculator, but it is easy to do the wheel and change it to exponential form. That would be the same thing as 6 to the second power equals x plus 1. I'm sorry, x minus 1. All right, so what do you got to do? 6 to the second power, and then add 1 to both sides, and then you would be done. Number 3, if you have a number that you're multiplying to your base, you have to divide that first. Before you try to rewrite anything, your base has to be by itself. So I would need to do 10 divided by 5 and get 2. All right, same thing. I could do y1, y2, or I could rewrite it as a logarithm. So my base is 2. My goal is to have that x plus 1 by itself. So my answer becomes my argument. And same thing, you can plug that right into the calculator. Log 2 divided by log 2. And then all you would have to do is subtract 1. And you can always use the wheel to go back and check. This should become 2 to the x plus 1 power equals 2. Alright, so hopefully in this video you have a better idea of how to rewrite exponential and logarithms. You understand where the base is supposed to go. And the purpose is to make it easier for us to solve in the calculator.